Today's lesson is on experimental probability. Experimental probability is a probability that is based on an experiment or a trial that you do yourself. So if you wanted to investigate what is the probability of a coin landing on tails when you flip it, you could get a coin and you could carry out an experiment where you flip the coin a lot of times and you record whether you get heads or whether you get tails. If you performed that experiment enough times, you would expect it to end up showing you that you have a 50% chance of heads and a 50% chance of tails, and that would be your experimental probability. You could, however, if you only flipped a coin 10 times, and 3 of those times it landed on heads, and 7 of those times it landed on tails, your experimental probability of it landing on heads would be 3 out of 10, or 30%. It would be different from what we know the probability to be, which is 50% or a half. But this would be your experimental probability from the experiment that you have carried out. So we're going to write down a definition for experimental probability. Experimental probability is based on an experiment or a trial. You can find out the number of times an event has occurred and use this information to predict probabilities for future events. So copy that down, please. Pause the video if you need to. So in what we've written down, let's say we were talking again about flipping a coin. The experiment or the trial would be the number of times you flip the coin, but a particular event would be an outcome that you are particularly interested in. So the experiment or trial could be flipping the coin overall, but the event could be it landing on tails. A very important point in experimental probability is that the more trials you carry out, the more likely that your probability is going to be accurate. So your experimental probability becomes more accurate the more trials that you do. So copy that down as well, please. Next, we're going to do this example. So copy this down. Laura throws a drawing pin in the air 20 times. It lands point up 6 times. Joanne throws a drawing pin in the air 100 times. It lands point up 43 times. For part A, remember this is probability notation. So find the probability of it landing point up from Laura's results and then Joanne's results. And then we need to comment on who is correct and why. So the key information here is how many times each of them threw the drawing pin and how many times it landed point up. Now, the probability that lands point up from Laura's results is 6 times out of 20, which simplifies to 3 out of 10. The number of times it lands point up in Joanne's experiment is 43, and that is out of 100, so her probability is 43 out of 100. So these are the probabilities. It's just the number of times the event happens out of the total number of trials, and if we can, we simplify it. Now, where it says who is correct and why, what do you think? Joanne has done more trials than Laura, so her estimate should be more accurate. However, we cannot know for sure, so we're going to write that down. So, Joanne has done more trials than Laura. So her estimate should be more accurate. But we can't know for sure. So copy that down as well, please. So we've talked about experimental probability, and we should also mention theoretical probability. So let's say we were going to record the outcomes of tossing a coin. And let's say we were going to toss that coin 10 times. Now we could do that and it would land on heads. Let's say it landed on heads 6 times. Our experimental probability then would be 6 out of 10, which is 60% or 0.6. However, our theoretical probability of landing on heads when we flip a coin is always 0.5. So here, our theoretical probability is 0.5, but the results of our experiment give a different probability of 0.6. Now, as we carry out more trials, we would expect this experimental probability to start getting closer to this theoretical probability. So perhaps we would do 100 throws this time, and we'd get 53 heads. Now that would give us an experimental probability of 0.53, which is much closer to, but still not the same as, this 0.5. So maybe we would toss the coin 1,000 times. We could end up with 511 heads. This would give us an experimental probability of 0.511, which again is closer, but still not quite 0.5. However, as we carried out more trials, we would expect this probability to get closer to the theoretical probability. So, theoretical probability is the probability we would expect in theory. For example, we expect the probability of landing on heads to be 0.5 when flipping a coin. So that is theoretical probability. Please copy that down. Pause the video if you need to, because the next thing we're going to say is, as you carry out more trials, or as we carry out more trials, our experimental probability should get closer to the theoretical probability. Okay, so copy that down as well, please. That should be enough for you to have a go at the question sheet. So have a go at the questions and let me know if you get stuck.